A recent survey of vehicle reliability has revealed a striking disparity between electric vehicles and traditional gasoline-powered cars. While electric vehicles have shown noticeable improvements over the past few years, they still face significant challenges that consumers and industry experts must carefully consider. The findings highlight a range of issues from technical malfunctions to safety concerns, pointing to the fact that EVs, despite their growing popularity, have not yet reached the reliability levels of conventional internal combustion engine (ICE) vehicles. According to the survey, electric vehicles were reported to experience 42% more problems than traditional gas-powered cars, a marked improvement from the previous year's findings, which indicated a 79% higher rate of issues. Plug-in hybrid electric vehicles, PHEVs, which combine a smaller internal combustion engine with an electric battery, were reported to have 70% more problems than conventional vehicles, also showing an improvement from a 146% higher problem rate observed the year prior. These numbers indicate that EV technology is progressing, yet there is still a notable gap when compared with the long-established reliability of gasoline-powered vehicles. The survey analyzed more than 330,000 vehicles across model years 2000 to 2024, including some 2025 models, and examined 20 specific problem areas. These areas covered mechanical, electronic, and software-related issues, giving a comprehensive picture of reliability trends in the automotive industry. One of the primary takeaways is that, although EVs have become increasingly sophisticated, they still face challenges that could affect consumer confidence, especially among first-time EV buyers. One of the most concerning aspects of electric vehicle reliability is related to autonomous driving systems, particularly those employed by certain high-profile manufacturers. Advanced driver assist technologies such as automated lane keeping and self-driving software have been linked to a series of crashes, some of which have resulted in serious injuries or fatalities. Investigations into these incidents revealed that unexpected vehicle behavior, such as abrupt lane changes, sudden slowing, or system misinterpretation of road conditions, contributed to collisions. These findings have raised serious questions about the readiness of fully autonomous systems for widespread use, and have highlighted the importance of maintaining a cautious approach when integrating advanced driver assist features. Beyond autonomous driving systems, electric vehicles face broader reliability challenges related to build quality and software performance. Many modern EVs rely heavily on touchscreens and digital interfaces to control critical vehicle functions. While these systems provide advanced features and a sleek aesthetic, they are also prone to malfunctions such as unresponsive touchscreens, system crashes, and software glitches. Such issues are particularly common in vehicles that emphasize digital integration over traditional mechanical controls. In addition, rapid production schedules adopted by several EV manufacturers have sometimes led to inconsistent build quality, with some owners reporting issues such as panel gaps, rattling noises, and uneven paint finishes. These build inconsistencies can impact not only the perceived quality of the vehicle, but also its long-term durability. Battery performance is another significant concern for electric vehicle owners. Lithium-ion batteries, which are the standard for modern EVs, are highly sensitive to temperature extremes. Cold weather, in particular, can cause a reduction in battery efficiency, sometimes resulting in a loss of driving range of up to 30%. This decrease in range is further exacerbated when the vehicle's heater is in use, which draws additional energy from the battery. For those living in colder climates, these limitations can affect the practicality of EVs for everyday commuting and long-distance travel. Hot weather, while less immediately impactful, can also reduce battery lifespan over time if vehicles are frequently exposed to extreme heat without adequate cooling systems. In addition to vehicle-related issues, the reliability of public EV charging infrastructure remains a major concern. Despite improvements in some areas, problems such as broken chargers, long wait times, and inconsistent payment systems continue to frustrate EV owners. In regions with limited charging availability, these issues can significantly impact the convenience and feasibility of owning an electric vehicle. While proprietary charging networks offered by certain manufacturers are often praised for reliability, access is limited to specific vehicle brands, which can leave non-owners dependent on less reliable third-party infrastructure. This uneven charging ecosystem highlights one of the practical challenges that potential EV buyers must consider, particularly those who frequently undertake long trips or do not have access to home charging options. Despite these challenges, the electric vehicle market continues to grow at a remarkable pace. Government incentives, environmental regulations, and rising consumer interest in sustainable transportation have all contributed to the increasing adoption of EVs. Many consumers are drawn to the environmental benefits of zero-emission vehicles, as well as the potential long-term savings on fuel and maintenance costs. Electric vehicles generally have fewer moving parts than traditional internal combustion engines, which can result in lower maintenance requirements over the life of the vehicle. Brakes, for example, tend to last longer due to regenerative braking systems, and there is no need for oil changes or certain other engine-related services. For many owners, these benefits are a compelling reason to consider EVs despite current reliability challenges. However, the continued growth of the EV market should not overshadow the fact that these vehicles are not yet flawless. Reliability, safety, and convenience remain areas where improvements are needed. Consumers considering the purchase of an EV should carefully evaluate their personal driving needs, climate conditions, access to charging infrastructure, and comfort with emerging technology. For some individuals, particularly those living in regions with extreme weather or limited charging networks, traditional gasoline-powered vehicles may still represent the more practical and dependable option. Looking ahead, the automotive industry is making strides to address these reliability issues. Manufacturers are investing heavily in battery technology, software development, and production quality improvements. New battery chemistries and thermal management systems are being developed to mitigate the impact of cold weather on driving range, while software updates and more rigorous testing aim to improve the stability and functionality of in-car digital systems. Similarly, efforts to expand and standardize public charging infrastructure are underway, aiming to provide faster, more reliable, and widely accessible charging options for all EV owners. Safety, however, remains a critical factor that cannot be overlooked. Autonomous and semi-autonomous driving technologies are evolving rapidly, but incidents involving unexpected system behavior underscore the importance of cautious adoption. Consumers must remain vigilant, understanding the limitations of current driver assist systems and continuing to engage actively in driving, even when advanced features are in use. Regulatory bodies and manufacturers alike are working to refine these systems, improve safety protocols, and ensure that future iterations are safer and more reliable. In conclusion, electric vehicles have made remarkable progress in recent years, achieving technological sophistication, environmental benefits, and an increasingly robust market presence. Yet significant challenges remain. Reliability issues, including software glitches, battery limitations, and inconsistent build quality, continue to affect consumer confidence. Safety concerns related to autonomous driving systems further complicate the picture, and practical considerations such as public charging availability and weather-related performance limitations remain relevant for potential buyers. Consumers must weigh these factors carefully when deciding whether an electric vehicle is the right choice. For some, the benefits of reduced emissions, lower long-term maintenance, and the appeal of cutting-edge technology will outweigh current drawbacks. For others, the reliability and convenience of traditional gasoline-powered vehicles may still be the preferable option. As the industry continues to innovate, it is likely that many of these challenges will be addressed, paving the way for a future in which electric vehicles are both practical and dependable for a wide range of drivers. Until that time, a cautious, informed approach to EV ownership remains the best path forward. The path toward mainstream adoption of electric vehicles is a journey rather than an immediate shift. While EVs are improving in reliability, every prospective buyer should consider their unique circumstances carefully. Climate, commuting patterns, local charging infrastructure, and comfort with emerging technologies all play a role in determining whether an electric vehicle will meet expectations. Ongoing technological advancements in infrastructure development will undoubtedly continue to reduce the gap between EVs and traditional vehicles, but patience, research, and careful decision-making are essential for anyone looking to make the switch today.